I'm going to go over the 3 problems in the study guide. The first one, during the first 15 minutes of charging, 800 coulombs of charge are deposited in a battery by an average potential difference of 12 volts. How much electrical work is done by the charger during the first 15 minutes? For this, we need to use the equation work is equal to charge times potential difference. Our charge is 800 coulombs. Our potential difference is 12 volts, giving us an amount of work equal to 9,600 joules. Number 2 says a solenoid on a car starter draws 16.5 amps at 12.6 volts. How much work is done if the solenoid is active for 1.4 seconds? So this equation is going to be work is equal to current times time times voltage. We have 16.5 amps times 1.4 seconds times 12.6 volts. That is going to give us 291.06 joules of work. Number 3 is a little bit messed up, both in wording and the numbers that I used, so it's going to be a little bit weird, but we'll just do it and account for it next time. A 25.2 volt motor uses a current of 4 amps to run a motor that provides the lift on a crane. If a 3,540 Newton I-beam is lifted 6.2 meters off the ground in 12 seconds, find the input work of the motor. This is going to use the same equation as above. Work is equal to current times time times voltage. Here our current is 4 amps. We're multiplying that by 12 seconds and 25.2 volts. That gives us an input work of 1,209.6 joules. The output work for part B is simply going to be work is equal to the force times distance. The force is 3,540 newtons times a distance of 6.2 meters. That work is going to be equal to 21,948 joules. Part C says find the efficiency of the crane. Efficiency is equal to work output divided by work input. Now, you probably saw earlier that our work output is 21,948 joules. Our input work is 1,209.6 joules. Keep in mind that your input work should always be greater than your output work. The numbers that I picked for this calculation make this absolutely impossible, but when you divide this, you get an efficiency equal to 18.14, or if you multiply that by 100%, an efficiency equal to 1,814%. Let me know if you have any questions.